This is part 2 of finding vector and parametric equations. Example, where does the line above cross the x-axis? Now the line they're talking about is from the previous page, and I'm going to pick this example. Generate the parametric equations. I'm not sure where that 7 came from. I'm sure where the 7 came from, not sure where the 6 came from. Okay. To find x-intercepts, let y be 0. Standard procedure in all math courses. That means I'm going to let that be 0. 0 equals 5 plus 6t. Negative 5 divided by 6 equals t. Now, the line will cut at that point. Therefore, the t that goes into this one should be the same as the t that goes into that one. Therefore, x equals negative 1 plus 7 and I will get negative 6 minus 35 over 6, negative 41 over 6. That means my line will cut the x-axis at that point. All right. Another example. Can the equation R also contain the points this and this? Now it's very similar to the previous question we've already done. My parametric equations will be negative 15 plus 14 over 3t, and y equals negative 7 plus 4t. Let's do point E. Negative 1, 5. Negative 1 equals negative 15 plus 14 over 3t. 14 equals 14 over 3t, cross multiply. 14 times 3 over 14 equals t. 3 equals t. Do the other parametric, in which I'll use 5. 5 equals negative 7 plus 4t. 12 equals 4t. T equals 3. They are the same, so yes. Points on the line. Let's repeat the process for the other point, F. 6, 11. 6 equals negative 15 plus 14, 3 over t. Jing jing, I'll get 21 equals 14 over 3t. 21 times 3 over 14 equals t. 2, 3, I get 9 over 2t. Not quite as attractive. 11 equals negative 7 plus 4t. 18 divided by 4 equals t. T equals 9 over 2. Again, they are the same, so the answer is yes. That's nice. Flip it over, last page. Determine the vector equation that is perpendicular to this one. Okay, that point would be a 4, 1. We got that. The slope is negative 3, 2. Negative 3, 2. That would be back 3 up 2. So back 3 up 2, we're going to get a line that looks something like this. It'll have a negative slope. All right. Now they want me to find the equation of a line passing through this point. And I'm going to put 6, 5 right here. And perpendicular. So my line is going to come down like this. Perpendicular. 6, 5. All right. As soon as I see the word perpendicular, I'm thinking dot product. M of this line is negative 3, 2. That's M1. This is M2. This will be I don't know. So I will get negative 3, 2 dot x, y should equal 0 because they are perpendicular. Negative 3x plus 2y equals 0. 2y equals 3x. Y equals 3 over 2x. This is the slope. M2, the components will be 2, 3. Now if I want the equation of that line, r equals x naught, y naught plus t M2. There's M2, and they gave me the point. There is my vector equation of a line perpendicular. Now a lot of this should have been familiar. We should have had negative reciprocals. The slope they gave me was this. So negative reciprocals. This is actually rise over run. That means the negative reciprocal should be flip it, change the sign. And in components it will be 2, 3. Here's some questions to do from the textbook. I hope this was useful.